We're back with limits. This time we want to look at limits algebraically. This will be a faster way of computing limits, and it'll give us more accurate answers. Let's start with an example. Let's take the limit as x approaches 2 of this function, x squared plus 5x. This is an easy one. As x gets closer and closer to 2, it's very easy to see what x squared plus 5x gets close to. We just put in 2, and we get 2 squared plus 5 times 2, and that's the answer. Turns out to be 14. This approach works whenever we have a polynomial here. That is, if we take the limit as x approaches a of a polynomial p of x, that's always going to be equal to what we get when we put a in for x. It's equal to p of a. That's what we did here. We took the 2, we put it in for x, and we got the answer. That works if p is a polynomial. Let's look at a more complicated example to see what we have to do when we have to enforce this x not equal to a business. So let's look at the limit as x approaches 3 of x squared minus 9 over x minus 3. This is a little bit harder. If we look at the form of this, we would get 3 squared minus 9 over 3 minus 3, and that works out to be 0 over 0. And 0 over 0 is not defined mathematically. It means that 0 over 0 is not going to be the answer, and we have to do something different. In this case, what we'll do is we'll factor. We'll take the x squared minus 9, and we'll factor it. We can factor it into x minus 3 times x plus 3. And that's pretty nice, because now if you look at this piece of an expression right here, the x minus 3's will cancel out. And if we cancel those out, we might say that this is equal to the limit as x approaches 3 of x plus 3. But let's stop right here and think a little bit more carefully about what we did. Why are we allowed to do that? Well, x minus 3 times x plus 3 over x minus 3 is equal to x plus 3 as long as x minus 3 is not equal to 0. That is, as long as we didn't cancel out a 0 over 0 form. But remember, x is not equal to 3. That's part of our limit description. X not equal to 3 is built into our description. Since x is not equal to 3, we can subtract both 3 from both sides of that and say x minus 3 is not equal to 0. So that means that we did not cancel out a 0 here, because when we look at the limit as x goes to 3, we only look at values of x that get close to 3, but x not equal to 3. So this cancellation is allowable, and that's the key step to finishing the problem. Now we have a polynomial. All we have to do is plug in 3, and we get 6. That's how to do limits algebraically. It's a very fast, very nice way of doing limits.